Hello, my name is Daniel Soto, and this is from Challenge 2016, the seminar video number 2. Okay, for this problem, we have x squared minus 9 all under a square root times dy dx equals 1. X is greater than 3, and y at x equals 5 is equal to ln of 3. So let's just make that a little bit easier. So it's essentially natural log of 3. The point natural log of 3 is equal to 5. Yeah, 5. Okay. Now, to do this problem, we're going to have to move some things around. Begin with, let's get the dy on one side, and then shift the dx to the other side. Okay, now we're going to divide over the 1 over the x squared minus 9 all into the square root. That's going to be on the bottom. Okay, now we can take the derivative of this. The integral. So this will turn out to be y. And that will be equal to integral of 1 x squared minus 9 dx. Okay, now we're going to have to do some trig substitution. It's theta. X squared minus 9. This, we can find out the trigonometric values by using Pythagorean theorem, which is a squared plus b squared equals c squared. Okay, so now we're going to have, right now we have x squared minus 9, 3 squared. And so that looks as though it's a c squared minus either a or b squared. We'll call it a for the purpose of this video, and then that's equal to b squared. So that means that x is equal to the hypotenuse, and then root x squared minus 9 is equal to one of the sides. Let's put it on the adjacent side, and this is equal to 3. This might be changed in a little bit depending on how difficult the formula gets with that. Okay, now I'm going to get rid of that Pythagorean theorem. Okay, so let's get so sine theta is equal to opposite over hypotenuse, so it's 3 over x. So we're going to make that into cosecant theta is equal to, 3 cosecant theta is equal to x, because with the cosecant you basically just swap these two values. So instead of being opposite over hypotenuse, it would be hypotenuse over opposite, since cosecant is equal to 1 over sine. And now we gotta find the value to plug in for the x squared minus 9, root x squared minus 9. So that would be tangent, but that would get us opposite over adjacent, and no, what we want is to have the root x squared minus 9 to be on the top, so we're going to do cotangent instead. So cotangent theta, 3 cotangent theta is equal to root x squared minus 9. Now back to this cosecant theta, we're going to have to take the derivative of this. So it is equal to 3 cosecant theta, cotangent theta, d theta is equal to dx. And that will be a negative, actually. So these are the values that we're going to be using. Cotangent theta is equal to x squared minus 9, all in the root, and this value for dx. Now to the next slide, but we'll plug them in. So let's do this in a different color. Y is equal to 1 over 3 cotangent theta, times negative 3 cosecant theta cotangent theta d theta. And so the cotangents will cancel out, so you'll have, and also the 3's will cancel out. So now you have y equals negative integral of cosecant theta d theta. And cosecant theta, the integral of this is equal to, so integral of cosecant is equal to, that's pretty good. Natural log, well, negative natural log of the absolute value of cosecant u for the purposes of this example. Cotangent, cosecant u plus cotangent u, absolute value, and then plus c at the end. So using this, let's plug it in. So we'll have negative of negative natural log cosecant theta, absolute value, cosecant theta plus cotangent theta plus c. And so the negatives will cancel out, so it'll be positive. So the answer we have is positive natural log of cosecant theta plus cotangent theta. Now we're going to swap in for those values, since we have those from before. So it's y is equal to x squared minus 9. Oh, that's a natural log of x squared minus 9 over 3. And so since we have cosecant theta, we'll just reverse it. So now we'll have, well, cosecant theta would be equal to x over 3. Sorry. So plus c. And there's your basic equation. Now we'll plug in some of what our original conditions were, and let's just streamline that a little bit, since you know with when we're taking logs, if we're dividing inside of the log, we can just turn that into another log like this. So natural log of x plus root x squared minus 9 minus negative minus ln of 3 plus c. Our original condition was that x is greater than 3 and that at at natural log 3 y is equal to 5. So using that we can plug in. So every x will plug in ln of 3. Oh, sorry, I messed that up. It's actually x is equal to 5, and then y is equal to ln 3. And so here's our actual point. We'll now plug in some values. So for y, we'll have ln of 3. Then we'll plug in for the other one, so natural log of 5 plus root 5 squared, so 25, minus 9, minus natural log of 3, plus c. So natural log 3 is equal to natural log of 5 plus, that would be equal to 16, so plus 4, minus ln 3, plus c. So this will be equal to natural log of 9, and then since we actually did an unnecessary step, so this subtraction of the ln of the natural log of 3 is unnecessary, so we'll just combine these logs again, so it'd be 9 over 3. The 9 is coming from the 5 plus 4, and then you just divide it by 3 because you can combine logs in that way, plus c. Just separate that one. So ln of 3 is equal to natural log of 9 divided by 3, so this will come out to be that c is equal to 0, since we'll have natural log of 3 is equal to natural log of 3 plus c. So our final answer is that y is equal to natural log, and we'll just combine them now. It was to get a better view of the problem as a whole. X minus x plus x squared minus 9 over 3. And there's a final answer. Thank you for watching, and I'll see you again soon.